When we take the derivative of anything involving the natural log, there's one piece of information that we need to remember. The derivative of the natural log is 1 over x, or 1 over the value inside of the natural log. Now, that may seem pretty simple. What we need to remember is that oftentimes we will need to utilize the chain rule to take the derivative of such. So let's look at a few examples. In number 1, I have the derivative of the natural log of 5x. What you should notice is this is a two-level chain rule function. So my outside would be the natural log, and my inside would be 5x. The derivative of 5x is 5. The derivative of the natural log is 1 over the value, so that would be 1 over 5x. So my final answer would be 1 over 5x times 5 over 1, which simplifies to 1 over x. So the derivative of the natural log of 5x is 1 over x. Now in number 2, we have a slightly more complicated but still two-level chain rule function. My outside is 3 natural log, and my inside is x squared. The derivative of x squared is 2x. Now pay close attention here. The derivative of 3 natural log is 3 over whatever started inside. So in this case, it'll be 3 over x squared. So I'll get my final answer by multiplying those two pieces. So I have 3 over x squared times 2x over 1. I'm able to simplify and take 1 x away from the numerator and denominator, which gives me 6 over x for my final answer when taking the derivative of 3 over the natural log of x squared. In number 3, I've upped it even a little bit more, where we have what I would consider a two-level chain rule, but it's got a trig function inside. So the outside would be 5 natural log, and the inside would be the sine of x. So the derivative of 5 natural log is 5 over whatever started inside. In this case, it is the sine of x. And the derivative of the sine of x is the cosine of x. So my final answer would be 5 divided by the sine of x times the cosine of x over 1, which would simplify to 5 cosine of x over the sine of x. Now, I would be 100% okay with you leaving it in this form, but if you want some bonus points, you could write that as 5 times the cotangent of x. Woohoo! Now, let's up our game even a little more, looking at some product rule problems that include the natural log. So in my first one, I have a product rule. I have x squared times the natural log of 5x, and I'm being asked to find the derivative. So I know it's a product rule because I have two separate functions, two separate things containing x that are being multiplied. So I'm going to set up my u and my v, u being x squared, the derivative of which is 2x. V will be a two-level chain rule function, so I have the natural log of 5x, the outside of which is the natural log, inside is 5x. So v prime ends up being 1 over x when I multiply 1 over 5x times 5. So now I find my derivative by taking v times u prime. So I'll have 2x times the natural log of 5x plus x squared, or x squared over 1 times 1 over x. This little beauty right here will simplify because I'll have x squared over x, which would simplify to just x. So my final answer could be 2x natural log of 5x plus x. In number 5, I have a natural log included in a quotient rule problem. And again, I know it's a quotient rule because I have two separate functions that are being divided. Remember, the quotient rule, if y is u over v, then the derivative is vu prime minus uv prime over v squared. So to do this, I will go ahead and write down my two functions, u being 3 natural log of x and v being x squared. U prime will be 3 over x and v prime is 2x. So choosing another color just to make everything stand out. Y prime would be VU prime. Now I'm going to simplify this right away because I see that 3x squared over x would simplify to 3x minus UV prime, which will give me 6x natural log of x over the denominator squared, and x squared squared is x to the fourth. Now you may notice that this one will simplify. If I take an x, factor an x out of the numerator, I'd have 3 minus 6 natural log of x over x to the fourth. And taking one x away from the numerator and the denominator, I would be left with 3 minus 6 natural log of x over x cubed for my final answer. Way to go, superstars.